Well, my calculus students, it'd be so much better to be in your presence than to be hiding out here in my bunker. It's kind of hard to teach to myself. I have nobody to catch my mistakes. I have no one to have jokes back and forth. So just bear with me. I'm going to do the best I can to give you the material to continue this course, especially for the college credit. They are really telling us no ifs, ands, or buts. All the material has to be taught for you to get the credit, and I'm going to have to verify that at the end. Uh, I sent you a message out yesterday that I will be giving you a test for that last unit 5. Please be on the honor system. Do the best that you can. Uh, there are ways for me to tell when you have done your work or not, and if I suspect that it's not honorable, then I'll have to talk to you on the phone and have you answer something for me. And we don't want to do that. We don't want to do that. Don't give me any reasons. All right, we're in Unit 6. This is about integrating, which you've already seen the introductory video. I think the big problem that we did a lot was we talked about the derivative with respect to x of something simple like x cubed. And when you take that derivative, that's 3x squared. I wanted you to also notice that if you did the derivative with respect to x of x cubed plus 5, that derivative also is 3x squared. So what we noticed was this had a plus 0 constant, this had a plus 5, so it didn't really matter. So in day 52, we're just talking about polynomials and basic trig. The assignment you did that I will give you a score on it. It was basic, should have taken you no more than 5-10 minutes to do after you watch the video. The video was very, very good. It was very good. It actually, uh, maybe you don't even need me. I can just give you the homework assignments and then have you do the homework and then have you do your My Math Lab, have you do cons, have you do all your, you'll probably be fine. But just in case, I can't move on without uh, at least pretending to try to teach this class. Let's get started. So the sooner I get this lectured, then the sooner I can post it. Okay. Um, if you had to explain to someone how to find the derivative of a polynomial function, that was one of the very first questions I asked you. If f of x was some sort of ax to the n, that's polynomial. Has an x value. It's not rational. There's no x in the denominator, and f prime of x would have been using that rule where the power goes in front times the a. You have the x. You take 1 away from the power. So that's one of the questions that was in your notes. To find the antiderivative, you would do the opposite of each of these operations. So here we multiplied by the n that I had up here. Well, we're going to be dividing by instead of multiply by. In derivative, we took 1 away. In the antiderivative, we add 1. So if I started with my f of x equals a, that's just a constant, x to the n, then the antiderivative, which is this squiggly little s, which has something to do with summation, you'll see it not too long, of a x to the n. And what we always did was, you might have seen it, that we always sandwiched it, this big S, with a dx, which just means that the derivative that you originally took was with respect to x. So that generic solution would be, we have ax, we have to add 1 to n, and then we divide by it instead of. But because you don't know what your original function had, let me put it over here, whether you're doing the derivative with respect to 3x squared, or whether you're doing with the derivative with respect to x of 3x squared plus 1, or whether it was the derivative with respect to x of 3x squared minus 10. Since when we did the derivative each time, that constant didn't matter. So therefore, your function that you get when you do the opposite of the derivative, there could have been a constant there. Just remember that if I was to have done the derivative of my answer, ax to the n plus 1 over n plus 1 plus c, then the derivative of this would have been, obviously the n plus 1 is my power. It's going to go in front. There's my a. There's my n plus 1 downstairs. And then the derivative, I have to take 1 away. So that gives me an n. Take the derivative of the constant, which is 0. So look what we end up with. That cancels. You end up with, I lost my x. A x to the n. A x to the n, which is exactly what I was doing the antiderivative of. So that constant could have been anything. Could have been a 0, could have been a 1, could have been a 10, and you still would get the exact same antiderivative. When you do the antiderivative, you still come back to the original function that I started out with. Okay? Moving on. So this is where he denotes this integral sign. I think it's called an integrand. And there's the dx that we put on the other side of the function. And basically, when we integrate a function, you could have pretended it was the derivative. And when you take the integral of a derivative, it cancels out to the original function. Likewise, this is kind of interesting. Well, I just did this a minute ago. If you do the derivative of the answer to integration, ironically, it comes out to f prime of x, which is what I had here. Those are inverse operations. All right, let's do some problems here. I'm going to go, these are just polynomials, so you can treat them as separate integrals. If that helps you simplify it. But normally I won't do that, but I just did it this time. So left to right, that becomes a 3x add 1, divide by it. And yes, technically there's a plus c there. Next one, plus 2x add 1, divide by it, plus a c, plus 3 is a constant. So you have to realize this is x to the 0. So x to the 0 is 1. 3 times 1 is still 3. So I take 3, add 1, divide by it, plus c. Now, in reality, this is a different constant than this constant, than this constant. And you put them all together, and what you have is you have just one big constant. So it would not be surprising if most of you just wrote the answer as, well, that's going to be x cubed plus an x squared, because that cancels, plus a 3x plus a constant. So I'm not going to break every single problem down like this because I don't want to put you to sleep. When you have a rational function inside your integral, just like we did when we learned how to do derivatives, we had to simplify. So we only know right now how to do polynomials. That's the rule I just gave you. So you're going to want to take this, put this together, put this together, put this together, and simplify it. So you really got to have x cubed divided by x, that's x squared. A 2x divided by x is a 2. And a minus 4 over x, interesting, minus 4 over x, you need to write it as negative 4x to the negative 1. Negative 4x to the negative 1 dx. Okay, so let's go ahead. That's going to be x cubed over 3 plus that's an x to the 0, so it becomes x to the 1 divided by 1 minus 4. Did he really put that there? Well, 4x to the, add 1. It's x to the 0 divided by 0. That's an issue. He should not have done this yet. Let's see. Why did he put that there? Well, I guess we're just going to have to look at it and use some common sense here. If you think about it, when you think about this error that it looks like is because you're supposed to have remembered something. That the derivative with respect to x of a natural log of x is du over u. So the derivative of du over u would have given me a 1 over x. Therefore, when you integrate 1 over x dx, that's natural log of x. So that's basically what you have here. You're integrating 1 over x with a negative 4 here. That negative 4 really doesn't change anything. It still gives you a negative 4 natural log of x. And just for safety reasons, we put that in absolute value just in case that x became negative. You can't take the natural log of a negative number. You have to absolute value it first. So I'm really surprised that he threw this really quick to you. That really is not correct. We say natural log of x plus c. Well, that took me by surprise that he was going to throw that so fast. What do we do with a product of two things? We don't have a product rule for antiderivatives. So you're going to have to use your FOIL or philo, however you want to do it. Rewrite it. That becomes 2x squared minus 3x plus 4x minus 6 dx. You don't have to simplify anymore and combine like terms, but it sure makes it easier if you only had to work with an x. And so, final answer, 2x cubed over 3 plus x, add 1 to the 1, that's a 2 over 2. This is x to the 0, so it's minus 6x plus my constant of integration. Do what I did a minute ago, even though it messed up because it was not, the power rule didn't work with 1 over x, but it should work with this one. Should work with this one. Matter of fact, I don't know if I gave you, I think I gave you one like this on your paper. So that gives me a 2. Negative half plus 1 is a half. Divide by a half. When I divide by a fraction, I do this. Divide by a half means I'm going to multiply by the reciprocal. So 1/2 goes up there, plus c. That's 4 square roots of x plus c. Now, I might be going fast for some people, but you can always just repeat it. It's the beauty of a video. Now, when we do our trig, we remember that the derivative of sine is cosine. The derivative of cosine is a negative sign. So it should not be a surprise to you that if I'm integrating both sides and I integrate cosine and I integrate this side, the integral cancels out the derivative, leaving the answer sine. So when I integrate cosine of x dx, it is just sine of x plus c. When I do the same trick over here and I integrate both sides, I get a cosine of x equals to a negative, well, actually is, what was I going to say? When I integrate, well, I guess the problem is just negative here. I want to integrate sine of x dx, but there's a negative there. So that negative goes to the side, which is why you get the answer of a negative cosine. So the integral of cosine, derivative of what is cosine? We say sine. And when I do the sine, it gets you the negative cosine. It's the opposite of what we did for derivatives. The derivative of sine was positive, but the integral of sine is negative. The integral of sine is negative. All right, let's practice this one. I should have shared with you. I'll do it on another problem when I get to, let's see. I'm going to share something with you on this problem right here. But for right now, there's two separate integrals here. So don't be afraid. That's just two different ones. The integral of sine is negative cosine. And there's a 2 out front, which really wasn't affected. The integral of cosine is positive. Now this is a polynomial with a trig. So that gives me t to the 3 over 3 minus the integral of sine is a positive cosine. And what I was going to share with you is that if I broke those into two things, 4x dx minus the integral of 3 cosine of x dx, I can technically factor out the constants. They really don't affect anything. That's why in my head I wasn't really too bothered by it. But I don't want to rewrite all those problems all the time. So this becomes 4x squared over 2 minus a 3. The integral of cosine is going to be positive. Sine of x plus c. And of course that simplified to this. Oh, I don't know why that erased. 4 over 2 became a 2. So 2x squared minus 3 sine of x plus c. Remember that this is really the integral of x to the half. Add 1 to a half. That means 1/2 plus 2/2 is 3/2. X to the 3/2 divided by 3/2 means divided by 3 times the 2. That's the reciprocal. The integral of sine is a cosine. negative. Oof, I almost lost it. Negative cosine. Okay, I have to pause for a minute. My doggy Diva just joined me, and she's going to be making noises. Cosine x dx. All right. See how much for. Use the given information about f prime and f double prime to find f of x. Okay. So if we start out with the second derivative of x, and we know it's equal to 2, the inverse operation of a derivative is an integral. So if I integrate both sides, of course, with respect to x, which kind of goes without saying, the integral cancels out one of those derivatives. So now I'm down to f prime of x. Obviously, plus a constant equals to a 2. That's an x to the 0, so it becomes x to the 1 divided by 1. I'm just going to leave it as a plus another constant. Now, what we tend to do is put all our constants on one side. This was a different constant than this constant. So look at it as f prime of x equals to 2x. And it doesn't matter whether I take away a constant over here from both sides. It's still one constant. So now I'm going to integrate it again. By the way, this is interesting. The video I sent you the link for the webinar that's going to happen today at the College Board about differential equations, I changed my mind. This is a differential equation. This really is a differential equation. I'm going to put back on the message, you should do it because it's very much related. And I think the video will stay there after it's played, even if you don't watch it live, I hope. Make sure you subscribe to the College Board. They got 3 lessons coming out. Anyway, here goes. Integrate both sides with respect to x, of course. That gives me down to just f of x, because the integral cancels out a derivative, plus a constant, but I'm not going to worry about it. I'll put the constant on the other side. That's 2x squared over 2 becomes x squared. And when you integrate a constant, which is just a number, it turns into what? An x. Whatever c was. Actually, I'll call it cx plus c. And, I already found f double prime right here. F double prime was my first answer. Let's see, to find. Oh, you know what? I didn't pay attention to this here. So what I could have done right here when I got my first constant, let me put that answer back down here. I had f prime of x was equal to 2x plus a constant. Up here, he's telling me that f prime of 2 was equal to 5. So f prime of 2 is equal to 2x plus c, which is equal to 5. This x actually is a 2. So that gives me 4 plus c equals to 5. Then c is a 1. So what I can do with that is rewrite this before I integrate it again. F prime of x equals to 2x plus 1. Now, when I integrate both sides like I did a minute ago, I get my f of x equals to the same thing I had. That made this into 2x squared over 2, x squared plus 1 times x is x plus my constant. See, it's the same thing as over here. But he gave me some more information. He said f of 2 was 10. Those are called initial conditions. These two things are called initial conditions. So now I can say if f of 2, which equals to 2 squared, plus 2 plus c is equal to 10, that's 4 plus 2, that is 6 plus c equals to 10. C is a 4. So I really have a better answer than I had a second ago. I had a good f of x up here. I had this f of x. But now I have more information now. I now know f of x is equal to x squared plus x plus that c was a 4. This first c was a 1. This c here is a 4. So there's the best answer. That was fun. I like that. All right, let's do another one here. I'm going to erase this. And for you, it's never erased because you can always rewind it and look at it. Here it goes. I got f double prime of x dx will be equal to, the reason I'm putting dx because let me not put it yet. F double prime of x is x to the negative 3/2. Now when I integrate both sides, that's where the dx becomes. They go together, it's a sandwich. That strips out one of the primes, so I have f prime of x now equals to an x. Negative 3/2 plus 1 is a negative 3/2 plus 2/2. That still gives me a negative half. Divided by a negative half, which means I do the 1 in the bottom and the negative 2 there, plus a constant. This time I'm going to be proactive. I know for a fact that f prime of 4 is 2. So f prime of 4 equals negative 2 times the 4 plus c has to be a 2. That gives me a negative 8 plus c is 2. C must be 10. So my new f prime equation is f prime of x equals to negative 2x to the negative half plus 10. So now I will integrate again, making my integral sandwich. The integral of f prime cancels out one of the primes. That's f of x is equal to 2. X to the half, a half plus 2/2 is just x to the half. Divided by a half, which means the same thing as multiplying both sides, multiplying by the reciprocal, which is a 2, plus 10x plus my constant of integration. And at the top, he says f of 0 is 0. So f of 0 is a 4 times the square root of 0 plus 10 times 0 plus c means c, this was equal to what, he said? Equals to 0. C must be 0. So the equation is f of x is 4 square roots of x plus 10x. And there is no constant there, so fabulous. Hope you're feeling peachy. I wish I was with you. God, hey, almost, well, because this is, my dog and my cats are looking at me like, you think we're going to learn this stuff? Right. Last page, then things work. And let's see if today is Wednesday. I'll probably give you until sometime the middle of tomorrow to get it done. An evergreen nursery usually sells a certain shrub after 6 years of growth and shaping. Yeah, that reminds me of my days of working with the Christmas trees back in Michigan. People don't realize all the work we do with Christmas trees. We plant them in the spring, little seedlings, and then that takes quite a while. And then by the fall, or before fall, we actually paint the trees that have grown certain height. Well, those are going to be harvested. And we actually walk around the tree and walk down lines of Christmas trees with a big thing of paint on our back, and we spray these Christmas trees. And then there's trimming in the summer where we walk around the trees with a machete and we shape them. And by the winter time, as some of the trees are ready to be cut, we cut them and they get thrown into the aisle or the row. And then we come by with a truck and we feed these trees into a baler, which ties them up with strings, and we throw them on trucks, and then we fill these trucks, and we do that, and then we are done in the Christmas tree industry until spring again. Anyway, why was I talking about that? Maybe that's how I'll know if you watch this video. I'll ask you, what did Mr. Cartwright do as a teenager? One of his many jobs. All right, this is a differential equation. dH dt is 1.5t plus 5. And so we know when t is in years and h is the height of the tree, the height is changing with respect to time. As the time changes, the height gets greater. The seedlings are 12 centimeters tall when we started. That's when we planted them. Okay? Find the value of the differential equation above when t is 3. Using correctness of measure, explain what this value represents in the context. So find the value of the differential equation. The differential equation is dH dt. He wants me to plug in when t is 3. That must mean 3 months. Is the time in months? No, it's years, in 3 years. So we know it's going to be bigger than 12 centimeters. So we know the change of height, 1.53 plus a 5. That's 4.5 plus 5, 9.5 centimeters per year, because it was height per year. This is a rate of change that when exactly the 3rd year approached, the tree was growing 9.5 centimeters a year. Now, if we were to put in a 2, we would have gotten 8 centimeters per year. So that must mean in the 3rd year, at that 3rd year, when it's ended, year 3, the tree was growing faster than it was when in the 2nd year. It's a differential equation. It's a derivative. All right. Find the equation for h. Well, here we go. We want an equation for h. What I need to do with this differential equation is separate these two variables, the dH and the dt. It looks like algebra, that we're really just canceling out the dt on this side. So in your head, you could have it's called separation of variables. So dH, there's my equation with the h in it, is equal to 1.5t plus 5 dt. To get the equation for h, I have to integrate both sides. And when I integrate dH, there's actually an invisible 1 right here. You don't see it. It's a constant. So when you integrate dH, you get h equals to 1.5 t squared over 2 plus 5t plus my constant of integration. You all know that half of 1.5 is 0.75 t squared plus 5t plus my constant. Well, that's a pretty good equation for h. However, I have a constant. Oh, wait a minute. I have an initial condition. The seedling was 12 centimeters tall when we planted it, when time was 0. So this is an h of t equation. So h of 0 is 0.75 times 0 squared plus 5 times 0 plus c equals 12 centimeters. H of 0 was 12 centimeters. That must mean c is 12. Now I have my perfect equation. H of t equals 2.75 t squared plus 5t plus 12. This equation models the growth of that tree. You can find the height of that tree at any given time. I wonder if I was trimming that tree for 8 years. In 8 years, h of 8, whatever this is, 0.75 times 8 squared plus 40 plus 12. I'll make this easy. This is 3/4 times 64 plus 52. And 64 divided by 4 is 16. Hey, somebody's already messaging me. 64, 16. So 16 times 3. 16 times 3 is 48. 48 plus 52. That's 100 centimeters. Not a very big shrub. Was not a Christmas tree. All right, one more. We're done. And it'll take me some time. It takes about a half hour, 40 minutes for the video to render, and I'll post it. A particle moves along the x-axis at a velocity of v of t equals to 1 over square root of t, only when t is positive. At time t is 1, its position is 4. So we got this particle moving left and right. It was here, now it moves here, now it may move here, now it moves here. The particle is moving along the x-axis, and it has a velocity. What is the acceleration of the particle? Well, if velocity of t is t to the negative half, acceleration, well, isn't that the derivative of velocity? V prime of t is the acceleration of t. The derivative of this would be negative 1/2 t raised to the, take 1 away, negative 3/2. And then we plug in the 9. So a of t is equal to a negative 1 over the square root of t cubed. A of 9 would be negative 1 over the square root of 9 cubed, which is a 9 times 9 times 9, and the square root of a 9 is a 3. That's a 3 times 3. That's negative 1 over 27. And he didn't give me any units, so I'm leaving it. Wait. T of 1. I didn't even use this initial condition. I wonder why. Oh, I was doing the derivative. Didn't need it. What's the position of the particle at 9? Where is this position at on this number line after it's been moving around for 9 seconds or 9 minutes or 9 hours? All I have is my v equation equals to t to the negative 1/2. How do I get position from velocity? It's the other direction, which means our friend the integral with respect to time. The integral of velocity is position, x of t. The integral of t to the half would be t, add 1 to a negative half, that's a half. 1/2 divided by 1/2, 1, 2, plus c. Now I'll use my initial condition. T is 9. X of 9 would be equal to 2 times the square root of 9 plus c is going to be a 4. 2 times 3 is 6. 6 plus c is 4. C must be a negative 2. So my x of t equation is 2 square roots of t minus 2. That's the equation. But he wants my position at... Did I mess up here? I messed up. This was supposed to be t is 1 is 4. Let me back up here. T of 1 is 4. T of 1 is 4. That gives me a 2 plus c. C is not equal to negative 2. C is equal to just a positive 2. So my equation changes. All right, now I got to do x of 9, which is 2 square roots of 9 plus 2. 2 times 3 is 6 plus 2 is 8. So on that number line, I don't know where he was going, but it at t is 9, he was at the 8. Wow. Wasn't that special? This is cool stuff. I would have rather been doing this in front of you. Got a little more. I'm going to post this homework separately in Google Classroom so that you can annotate it, do your work, and resubmit it back to me, or however else you want to write on it, take a picture, all those. Okay, you have an assignment. I would suggest get working on this, and I'm going to start posting this on my YouTube channel. I will send you the link. Everything is going to be at Google Classroom, so I can monitor who watches the videos, and I can get the homework so I can grade it easy. I miss you guys. Please be careful and be safe.